Okay, so how do we determine the resist of the resistor? So we can see that for this one, there's the first one, the first band is brown, which means that is 1 in here. The second one is black, is 0. So for the third one, which means the multiplier, it means that this one is, in this case, is orange, which means is 1K. So 10 times 1K is 10K. So to double check the resistance of a resistor, we're gonna test it with the ohm meter over here, and we're gonna connect the two ends over here at the ohm meter, and we're gonna double check the reading whether it's 10 ohms or not. So it's 9.83 on the meter, which is fairly near to 10 ohms. So in the third step, we were required to connect two identical resistors in series, and we were required to find their resistance in total. So over here on the breadboard, we're gonna connect two resistors in series, and we're gonna check out the resistance on the ohm meter, which is supposed to be twice the resistance of one resistor connected. So we have a reading of 20 ohms, which is fairly near, close to 19.7 ohms, which is very close to 20 ohms. So for the fourth step, we just measure the resistance of three resistor. So for here, we got 29.5, which is fairly near to 30. And then for fourth, yeah, so for the four resistors, the resistance adds up in a series circuit. So for the fifth step, we are using two identical resistors and put them in parallel. So the resistor should be equals to 5. And let's check it out. Yeah, so here we go. Start. According to the sixth step, we were supposed to connect three resistors, identical resistors in parallel, and we were required to measure the resistance in total, which is around 3.28, 3.27. So for number 4, the first step, we have made the graph for the resistor in parallel. For x-axis is in the independent variable, which is the number of resistor. For the y-axis, we got the dependent variable, which is the resistance. So according to step number 6, we were required to note down the readings by connecting the identical resistors in parallel, and then we were supposed to plot a graph of the readings on MATLAB. And here's the graph of the readings. On the x-axis we have the number of resistors plotted against the y-axis where we have the resistance. For the seventh step, we have created a board with two parallel resistors and a light bulb LED in series. According to the Kirchhoff's law of conservation of energy, the sum of the potential difference across all the loads in a circuit should be equal to the potential difference being applied by the power source. So over here we have two parallel resistors connected into the circuit in series with an LED bulb. So the resistance, the potential difference across the resistors is 2.17 ohms. Is 2.17 volts, whereas across the LED it's 3.01 volt, which sums up to 5.19, which is actually the total potential difference being applied by the battery. So for the current in our circuit, it's gonna be the same throughout the circuit, except for the point where it splits at the junction where we have two resistors connected in parallel. According to the Kirchhoff's junction rule, it states for a given junction in the circuit, the sum of the currents leaving is equal to the sum of the current entering, or vice versa. That's it. So the current flowing in our circuit is constant throughout the circuit, except for the point where it splits into the junction where we have our two resistors connected in parallel to each other, according to the Kirchhoff's junction rule, which states that the sum of the current entering equals the sum of the current leaving. So the current that we have passing through each resistor is somewhere close to around 219 microamperes, whereas the current passing through the bulb is around 433 microamperes. So for section C, we were supposed to like get two resistors and measure their resistance for every resistor. They're supposed to be different, not identical. So one has a resistance on the ohm meter as 1 kilo ohm, and the other one has a resistance of, let me just hold this for a sec, 10 kilo ohm. For this one, we have connect to different resistors in parallel. So for this one, we got the overall resistance of 8.892 kilo ohms. So the inverse of the equivalent resistance of two or more resistors connected in parallel is the algebraic sum of the inverses of the individual resistances. So over here we have four different resistors connected in parallel to each other, and the total resistance across the circuit over here is 0.863 kilo ohms. So in section C, which is the last part, we're supposed to explain how can we explain Ohm's law experimentally. So for that, we have four different resistors. We're going to plug every single resistor into the circuit one at a time, and we're going to calculate and write down the values of the current which is flowing through the circuit, along with the potential difference of being applied, which is like the control variable, and the resistance of the circuit, which we already recorded in the previous video. So by this, we're gonna record a bunch of readings, and we're gonna state at the end that the relationship between V is equals to IR is true for Ohm's law. According to the previous video, we got the experimental value of 0.863 for the parallel resistance. So we got four resistance in parallel, which are 1K, 10K, 1000K, and 27K. And by the Ohm's law, we can use this formula, and we can find out that on the left side we got 1.138, which is equal to the 1 over the inverse of the total resistance. So if we calculate it, we can get 0.879, which is very close to 0.863 in the experimental value.